Well, hello from Emerald Hill Skies. My name is Doug, and thanks for your patience tonight as we try to sort through what I can only think is perhaps a change as a result of changing our internet settings here. We've gone to gigabyte internet, and for some reason, it looks like that maybe threw us off a bit. So now I think we're live in the stream. Let me just see if our audio is there. See. Yeah. Thanks so much for those of you who are patient. Appreciate that. The next problem that we're going to work with, let's see if we can get our normal background music going here. We use typically a selection from Stellar Drone, something like that. Okay, so we'll let that run. And now the next thing we've got to work out is, boy, I guess it's been 2 or 3 weeks since we've done a broadcast. And the next thing we have to work out is we have a problem with our mount. I hope you guys don't mind us trying to troubleshoot. Now, we do have the camera up and running. You can see there's Polaris, and stars are looking pretty good, even though we haven't yet focused tonight. And the problem is we can't seem to get our mount to work. Watch what happens. We bring up the iOptron mount software, and it says everything looks standard. Then we hit OK. It comes back and says, oh, it worked. How about that? Thank you, Lord. Okay, so we're going to say 0 position, set current position as 0 position, sync the time from the PC. And then next thing we're going to do is, let's see, I guess the next thing we're going to do is connect. Let's focus really quickly just to make sure. So we're going to close the camera here in Sharp Cap and bring up Nina. Thanks, Stu, for your patience. Ray, thanks so much. You guys were golden to let me try to work out that stream problem. I had to create a new stream. And like I said, I don't know if that was a result of changing internet speeds. It's possible because, and there's the focuser, so now everything's working. I'm thrilled to be able to say, now we're going to start this autofocus routine. We're operating tonight from the outskirts of Louisville, Kentucky. We have about a Bortle 5.5 or 6 light pollution that's pretty standard. And sadly, we do have a 95% moon tonight. We're using this Celestron RASA 11-inch on an iOptron CEM70G mount, and that sits on top of an adjustable height, a Pier-Tech Adjustable-Height pier, which is mounted to a whole bunch of concrete. And around that is an observatory that has a roll-off roof. It's a Pier-Tech Tele-Station 2 observatory. You can see down there at the bottom of the adjustable height pier, there's a little black box, and that's a little rack that's waterproof. You can take the front and the back sections off, and it has all the power and distribution, USB boxes and all. Because we have multiple cameras, we have up on top of the scope a ZWO ASI2600MC monochrome camera. That's the little red camera that you see there. It's got a little dew strap around it. It has its own little dew strap. And it connects to a USB hub by Pegasus Astro, and it has a little power box there to power it separately. And also the camera on the front of the scope. It's a ZWO ASI2600MC Pro, a color one-shot astro-camera. That connects to an Octopi-Astro interface, and that connects to the glass corrector plate on the front of the RASA. So you can see that the RASA really doesn't have any kind of eyepiece. It connects directly to this astro-camera, and we use the camera as the eyepiece. And that way, all of us can watch together. Not only I, here in this little observing station that I've got set up in my office 200 feet from the observatory, but also you are able to watch at the very same time I'm watching. So it's real-time astronomy as a group. It makes astronomy like a team sport for sure. And this little observatory is cool. It's got a roll-off roof with a little, kind of like a gate opener from a big, industrial yard where you let, 18-wheelers in and out of your industrial yard. It's got a gate opener like that for a giant gate, and that rolls that roof off, and then that adjustable height pier raises the telescope up, and you can see we just barely get it set so that it can see across the top of the observatory. You're looking through the front door of the observatory there to be able to see it. We've got those red lights turned off, so the observatory is actually pretty black. Let's see if we can get a camera set up so you can see the sky. Let's see, we'll use that 178 monochrome camera to, well, it's not showing up yet in sharp cap, so that's sad. For some reason the 178's not working. But the good news is we did focus okay. So you can see a nice little parabola, a nice little parabola here that should have set up our focus okay. So we'll go back to the equipment and disconnect this stuff in Nina, and then we'll close Nina. We'll go back to sharp cap and reconnect. You can see that the 178 camera is not showing up as a choice here. So for some reason we've lost that tonight. That's sad, isn't it? But anyway, we do have, let's get our dark set. I shot new darks tonight, brand new darks. We'll put those there, and new flats. So we'll grab those. There we go. Brand new darks and flats, so hopefully that'll be helpful. And now then, let's good, our mount connected correctly, and I think I'm going to close Stellarium and reopen it, because when we opened Stellarium, it did not connect to the mount because the mount wasn't working at that point. So we're going to connect again to Stellarium. Now, here's the thing, it's 8:12, so the question is, has Venus already set? So let's, oh, I'm afraid it has, but let's try it at least. So gonna call up our little controls here, and we're gonna see how close we are. Current object slew, and we're just gonna have to trust that the telescope is slewing correctly, because we don't have a camera tonight that's working to be able to watch it slew, and we also don't have a camera sitting on top of the scope to be able to see the sky. So two of our cameras didn't open tonight, sadly. Boy, if that's it. Yeah, there we are in the treetops. See, I don't know if we're going to be able to, if there are enough stars there that we can plate solve or not. Let's see if it can pick up enough stars to plate solve. And you can see it is setting through the treetops because of our delay getting started. I'm looking at your comments here. Use Nina to focus. Yes, exactly, Ray. No, that's right, Stu. They're too far apart. We missed, there were storms for the last 3 nights, Oh, looky there. So that would be Jupiter right there, and Venus should be above it. So what we're going to do is, let's think. We're out at a full frame. Let's go here and zoom in, and let's set on this star and slew to that star and see what happens. So we're gonna, Venus and Jupiter were in a closer conjunction, about maybe a degree apart on, let's see, when was that? March 1st, so that would have been Friday, Thursday, Wednesday night, I guess. Yeah, when we go to the middle of the frame, we don't get either one, sadly. Let's go up to Venus and let's have a look at it. So here's Venus. So bright, isn't it? Let's drop this to maybe 0.5 milliseconds. I'm sorry, 0.5 seconds. And maybe if we drop, you can see a little more of the planet's structure. There we go. So Venus is pretty full now, not a crescent at all. So we have it in the phase that it's full, and there you go. So see, it's pretty full. It's a little bit shaded on the top side, we're told here by Stellarium. And I suppose we could see that, couldn't we? Let's go to 0.25 seconds. Still too bright, 0.1 second. Let's drop our gain down to about 0 and see what happens. 50 milliseconds. Okay, now we're starting to see that Venus is not quite full. You see this shaded. Let me go ahead and pass our optical zoom and try to come in as close as we can. Can you see over here on this side, we're now able to see that Venus is not full. Now in this case, the RASA is sitting on its side. So here you see the shaded part on the right-hand side. Here in Stellarium, it's on the top. But the RASA out there in the observatory is on an equatorial mount. So this is the top over here on the right side. So that would be Venus, and that's about all we're going to be able to see. We're not going to be able to see the two of them together. So anyway, we missed out because there were storms on Wednesday night. Good to have you here from St. Cecile, New Brunswick, David. No slew cam, ruined stream. I'm out of here. Stu, that's great. Hello, Jeff. Good to have you here from out there in Montana, I think. Tim, good to have you here from the Netherlands. You are up late. My goodness. Good to have you all here. Okay, so I suppose we've missed this conjunction, and I guess we're going to have to go back now to prep for next target cycle. Now we're going to go here to our targeting software, and we're going to connect to the telescope here, and we're going to run this sorting routine again, and we're going to start with a galaxy, NGC 3726. So let's slew to that. Again tonight, we don't have, this is NGC 3726. We don't have a view of the of the telescope tonight, sadly. That camera is not showing up. Let's see, title on screen. This is NGC 3726 Galaxy in Ursa Major. If you've been following us for some time now, we've been working our way through the Herschel 400 list. So that would be 400 different objects, and we're using Stephen James O'Meara's book. He basically takes each object and writes a little write-up about it, provides charts and maps and descriptions, and he's using a 4-inch refractor, and we're using an 11-inch RASA, so a little bit different setup, but at the same time, it at least provides us with some background to the material of each object. So our first one is NGC 3726, and what we do basically, if you've tuned in before, is it's on page 130, we find the spot where Stephen James O'Meara talks about each object, and we're looking at just the objects that we haven't observed. I think we're down to the last, I don't know, 100 objects or so, 130 or so objects maybe left out of the 400 that we haven't hit yet. And it looks like there are 57 tonight available that we haven't hit. What this sequence does that you're watching, it automatically plate solves so that we're able to make sure that we're on the right part of the sky, and then it starts the live stacking. That gives us a chance to look up this 3726 GC 3726, sorry, 119 it's on. Stephen James O'Meara might just be the most well-known visual observer of our generation. He is, why are we not seeing 3726 here? Looks like I've gone twice the index, 3726, 119. Seems to be a problem with his index because 3726 is not on. It's on 120. He missed by a page. He says that it's a relatively large, low surface brightness galaxy, and it's very much like that of a dim comet just beginning to shine. He says it's like a comet-like glow with a weakly condensed inner lens surrounded by a dim circular halo. You have to use averted vision. It's an amorphous glow. An 11th magnitude star is projected against its northern flank. So what we're going to do here is reset our display histogram. Let's make this a little bit bigger. Move this observing software off the side and keep expanding this to make it bigger for you. His books are expensive, you're right. Stu says it's 45 million light years from Earth, gives its apparent dimensions. 3726 is about 85,000 light years across. Okay, now we're going to reset our stacking histogram. We're going to do a color balance, bring our blacks up to about right here, and our mids up. And right there in the middle now, you start seeing the galaxy form up. I like this set of flats a lot more already, I can tell you. So there's the galaxy, and that's 100% of the RASA's frame. We'll keep bringing our mids up, and you can see what O'Meara was saying. It's like an amorphous glow. It actually is pretty wide across, though, in terms of its angle of extent. I don't know. Let's see if we can. Does he not give the angular 4 minutes, 4 arc minutes wide? I guess we're getting used to these smaller targets in the Herschel 400, so that actually looked big to me compared to some of the stuff that we've been viewing. Let's zoom in a little bit past visual limit, and now you can see the arm starting to form up after just 3 minutes of live stacking. Look at this arm that's starting to form up out here. So this is NGC 3726. It is one of the objects that... So what we're going to do now is we'll go here in our targeting software and say show chart. And it will... So that's the way he has, that's the way Stellarium has NGC 3726 represented. It is so small in Stellarium. There's just basically a dot there, huh? And really that star is that 11th magnitude star that's right here, you see. That's kind of superimposed on the edge of it. Weakly condensing 11th magnitude stars project against the northern flank. There's also this star. Let's see if we can back off enough. No. That's about all Stellarium shows. Tell you what, let's go back out to, boy, it's looking better, isn't it? Look at that. You can now make out a little more of the arm structure. Let's put our blacks a little bit to the left of this crest. NGC 3726, that's actually looking pretty good. Let's see. We're going to kick off our first observation here. And with our first observation, we have to choose our there's our session, and we say NGC 3726 is 4 arc minutes of extent, 85,000 light years across, according to Stu, at a distance of 45 million light years from Earth. Stu also adds, it's a spiral galaxy with a small bar seen with medium inclination. See that bar there in the middle? That's what Stu is noting now. It's just barely visible. Let's brighten it up just a little more if we can. This is 6 minutes of integration. Just a little bit of a bar there across. And it's 1.38 arc seconds across. It ends at an inner ring with 1.5 arc seconds diameter. Wow, that is small, isn't it? Barred. Looking very red. Where are the blues? I don't know. This seems to be a balanced color. I guess there's more hydrogen coming through than there would be oxygen, perhaps. Yeah, Mike says he can see the bar. All right, we're gonna call it at that, just because 7 minutes is about the longest we try to stay on any one thing. So let's run our list again. And the next object we have is also an Ursa Major. It's NGC 3675. So we'll save a quick snapshot of this. And go back to our sequencer and say next target, and this is going to be NGC 3675, and we'll say slew to that. We kind of have to imagine what the slewing looks like by watching it in the telescope tonight. And so there you can see the movement of all the stars, kind of like you're in a Star Trek starship. You know, we didn't move very much, did we? This is very close to the last location, isn't it? We're going to say the mount is settled. Look at that. Those are crystal clear points of light. Nina did us right on the focus. Even the stars are red and orange, though, Stu says. Well, we'll see if we can tune up. It could be the effect of moonlight because the moon is rather bright tonight. 3675. Oh, right here. Yeah, it is next to it. It's a fairly bright spiral galaxy near 5th magnitude, 56 Ursae Majoris. With its bright core, the galaxy is a good object for small telescopes and prominent objects in larger telescopes. I can see it there in the middle. Just a faint blob so far. Its 4-minute-long ellipse oriented north-south that swells with averted vision. The inner core is very bright and the halo is quite diffuse. A magnification of 72 reveals a bright inner lens about 2 arc minutes across, surrounded by a mottled elliptical halo twice that extent. So about 4 arc minutes is all. Some concentration in S-shaped spiral structure can be discerned. Very nice object for small telescope users. Okay, so the suspense kills you, doesn't it, when it collects that first 20-second frame, and there it is in the middle. Let's do a reset of our display histogram. It kind of likes that. There we go, and then let's reset our stacking histogram, and we'll put our darks right there maybe, and back off our mid some. See, brand new darks, brand new flats. This is a little bit warmer night. Let's get our USB controller up and our pocket power box controller. And it tells us the temperature out there is 43.5. That's actually pretty decent temperature for tonight. It wasn't uncomfortable at all setting up out there. 3675 is located at a distance of around 50 million light years from Earth. It's about 100,000 light years across, Stu says. Nice, Stu. Thank you. I'm going to add an observation of 3675. This 4 arc minute wide spiral or elliptical galaxy in Ursa Major should do a new title, shouldn't I? 3675 is about 50 million light years from Earth and 100,000 light years across. So it makes a good match, doesn't it, for the width kind of our own galaxy, the Milky Way, which is also between 100,000 and 150,000. Look at that bright core. What does that remind you of? Maybe that black-eyed galaxy, about the same vantage. Look at that bright core. That's with 3 minutes of integration. You can already see the outer arms starting to shape up, can't you? It's pretty amazing, isn't it, that at 50 million light years away, we're able to see those arms after just 3 minutes of integration. You know, integration meaning the combining of frames, and that's what we're doing here. So far we've taken 12 exposures, and each exposure is 20 seconds at a gain of 100 on this ASI2600MC Pro. And the software averages those exposures as it stacks them, and what that does is it brightens the lighter points and it darkens the darker points. There goes a satellite across our frame. By brightening the brighter points and darkening the darker, we get rid of a lot of the grain, and we also are able to get rid of a good bit of the light pollution, which is actually rather rampant here in suburban Louisville. Bortle 6 skies we have, and because of the fact that that light pollution sort of tingles, it doesn't stay the same like a star. It kind of glistens and moves. SharpCap, which is the imaging software we're using, is smart enough to realize that it can drop out all that tingling, the grainy look of the light pollution. So a lot of that light pollution drops off. You know, nobody in their right mind in a typical suburban sky would try to view this galaxy in Bortle 6 skies with a regular telescope through an eyepiece on a night when the moon is 95% lit, 95% full. You just wouldn't do it. But with electronically-assisted astronomy, the style of astronomy we're doing here, you get a pretty decent image. I'm going to go into the zoom now with the camera's digital zoom. Let's pull one shade off of all that grain. Look at that core. See this dust lane here in the middle? Even though this galaxy is 50 million light years away. Let's take a look at this in Stellarium. We're going to go over here to our observing software and let's see, 3675. Go to our NGC 3675 to our planetarium software. Yeah, see, Stellarium doesn't even have an image of it at all. It's just black. It doesn't even have a Hubble view of it or anything. There's the field of view of our RASA, and as we zoom in, there's nothing there. NGC 3675. Well, there's 7 minutes. We'll save an image of it, and we're making good headway in this Herschel 400 list. Let's head to the next object, which is a galaxy NGC 34. Why don't we go to 3665? 3665. I'm going to slew to it now. We'll change the name here, 3665. And looks like the mount is settled. And then down here in the title, we'll change this to 3665. Again, it's a galaxy in Ursa Major. I always forget that we actually can look now over here in our observing software, and it tells the size of the object in angular extent. This is 4 minutes by 3 minutes, 4.3 by 3.3 in arc minute size. And we're up at about a 36-degree angle. Let's show the chart on that. So here's where we are, 3665. Let's back off and kind of see where we are. This is east, and that's northeast. So we're basically just east-northeast. You can see here's Ursa Major. So just for orientation, there's the North Celestial Pole. Remember those pointer stars point you to the North Celestial Pole. Well, if you go the opposite from the North Celestial Pole with those pointer stars, you're basically just running over the top of where this galaxy is located. Again, no real representation of it here. That looks like a radio galaxy form of it. How about that? It's just a blob. 3665. I'm going to adjust the display histogram and then the stacking histogram. Let's do a color balance. Move those mids off. When you start, you can't move the mids up as high. We'll put the black level right here, just barely to the left of the crest of those color balances. And here's the object right there forming up. Just so you see how small that is, relatively speaking, that's 200% of what our optical sensor can do. Yes, Ray, we're remembering now, since you've gotten us oriented to restretching the live view, we're remembering to do that now. You were the one who trained us to do that. NGC 3665. NGC 3665 is on 123. Pretty close in this batch that we're looking at. It's a small and relatively faint spiral galaxy midway between fifth magnitude stars 55 and 57 Ursa Majoris, in small telescopes as seen under a very dark sky at moderate magnification. It's visible only with averted vision as a moderate glow 1.5 arc seconds wide. How about that? This is one of the smaller objects in the Herschel 400 list. Nearby field stars give the illusion that the galaxy is elongated. At 72 power, the galaxy appears soft and elegant. Soft and elegant. With a slight brightening toward the core, the outer halo is tight and round. With averted vision, the halo extends slightly to the north, northeast, and south, southwest. Yeah, that's true. And that's all O'Meara says about it. O'Meara observes from the dark skies in Hawaii. Lives in a town there called Volcano. And once, while I was in Hawaii, I got to drive by his town. Wasn't sure I saw his house, but some locals told us that's the house where he lives. So for whatever that's worth, I must have looked in his dining room window, and I didn't become like some kind of a paparazzi and go up and try to, knock on his door, but it was fun to see where O'Meara lives. And then what he does is he goes out to some of the darker, uninhabited parts of Hawaii, even up on Mauna Kea, and does his observing with a 4-inch refractor. So you can see what he's saying about this. He basically says, this, I'll back off to 100%. That's 100% of the optical capabilities of the 2600MC Pro. So this is a very small object. It barely looks like a cloudy, fuzzy star, doesn't it? See, compared to these pinpoints around it, these stars, I mean, look at this star here. It has enough glow burning into this camera that it's actually about the same size as NGC 3665. What's amazing is that back in the, 1800s would this be? Would this have been discovered by Herschel in the 1800s, that this thing stood out to William Herschel? Stu says it's a lenticular galaxy located in the constellation Ursa Major, distance of 85 million light years from Earth, about 85,000 light years across. So we'll just do a quick observation of that. By saying a quick observation, I mean we'll record our notes. NGC 3665 is a lenticular galaxy. About 1789, Stu says, is when William Herschel discovered this. In Ursa Major, around 85 million light years from Earth and around 85,000 light years across. How in the world did William Herschel ever see this in his 18-inch homemade telescope back in 1789 from Bath, England? His eyes must have been super sharp. And also his sisters too. I understand Caroline did a bunch of these. Yeah, the best averted vision ever. You're right, Stu. Well, I'm afraid this is the most we're going to get out of this. It's just basically a fuzzy blob. But we'll try to brighten it up some and zoom back in. I mean, there is an outer glow, isn't there? But not very bright glow. It's about the best we can do with 6 minutes of time exposures added together. 6 minutes of combined 20-second time exposures averaged. Super squints for sure, Stu. All right, we're making progress here on the Herschel list. Next target, let's pick one out here, is we can go to, let's stay in Ursa Major and go to 3877. NGC 3877. NGC 3877. This is 5 arc minutes of extent by 1 arc minute, so it must be more edge on, huh? 1 arc minute of extent. $38.77. Mount has settled. This little sequence I have in the description of this video. So if you use SharpCap, you can actually study that sequence if you like, and you can program your own variation of it. You know, improve it. You can change the time exposure and the gain to match your settings that you need for your setup. And the advantage of this script is it takes care of all those little steps so that we can do things like look up the object in this O'Meara book, for example, and that's all happening kind of automatically for us without us having to worry about it. So I really like SharpCap's ability to do this sequencing. 119 again, kind of staying in Ursa Major tonight for a while. Yeah, it's a very small and dim galaxy immediately south of 3.7 magnitude Chi Ursae Majoris. In small telescopes, it appears very stellar and can be seen only when you know exactly where to look with averted vision. It's best seen at moderate magnifications. He says he couldn't even see it in his 4-inch until he had changed it to 72 power. Even then, it was just a fleck of fuzziness with averted vision, and that's from a very dark sky. He says the galaxy's nucleus and round central lens is visible. Larger scopes will show it as a dim, 4-minute-long needle of light oriented northeast to southwest. So let's see if we can see this needle. Oh, yeah, right there it is in the middle. And we're going to reset the display histogram, and then we'll reset the live stacking histogram. And always those mids are too far over, so I'm going to have to put that, see if we can put that in our sequence. Now the reds in this case are not dialed up as high as the blues and the greens, so we'll kind of straddle maybe just a little bit to the left of the red crest. And then let's, oh, there's the needle right there in the middle. How about that? So this is about 4 arc minutes long and just 1.2 arc minutes wide. Might even stretch to 5 arc minutes if we image it a while. Look how close it is to that Chi Ursae Majoris, 3.7 magnitude. So I think with a regular telescope, that glare would hurt your chances with an eyepiece of seeing this. Wow, we're looking at edge on, huh? This is 3877. Let's show chart on this. So what that does is instantly cues it up in Stellarium, but again, there is no image in Stellarium. It's just got the galaxy symbol. So really we should go back and paste all of these images in. Now is this double star 41? So this must be the Chi star, which, you know, O'Meara just describes it as Chi Ursae Majoris, but Stellarium shows it as a double star. Looks like it's a separation of 66 arc seconds, so not quite an arc minute. I guess if it's that one, can we tell that's a double, can we? We can't, can we? But you can tell it's a little bit more oblong glow, can't you? But the glare is killing it. But wow, look at the galaxy here. That's cool the way it's got that greenish tinge for us, isn't it? And right there in the middle, look at that core. We've got about 16 on the stream. If you haven't identified where you're observing from tonight, we'd love for you to do that. You could just say, you know, your name if you want, your first name, and that you're logging on from, and then whatever city or state or town. Ray is going to try to follow along, and he has to wait for it to get dark. Ray, I think, is located in Arizona, so darkness is just chasing over his direction. You might be in a different country, so feel free to tell what country you're in. Also, while this is forming up, we're at 4 minutes now. Might also mention that some of you have asked in the past about getting some kind of hoodie or something. So I'll mention that we do have now this, if you go to YouTube and you look up our channel, you can just search for, I think, at Emerald Hills Skies now. I think they've added that. And yeah, right there you are. You start picking up, you know, sessions. And then I'm going to pause that. And then what you can do is go to the channel. Oh, that's Pete Gallup, sorry. You can go to the channel, and the channel is Emerald Hill Skies. And then look at the store. And you can actually see like different kinds of stickers and bags, tote bags, and shirts and mugs. And then if you click on that link from Spreadshop, it'll take you to the Emerald Hill Sky store, and at the store you can actually look at all kinds of products that don't fit. For instance, hoodies. You can shop for all kinds of hoodies, and you can get them with, you know, dark or light imprints, and you can choose from organic and premium, and, you know, just pick your price point. You can get magnets, backpacks. How about that? I hadn't noticed that there were backpacks. You can get women's long sleeve, men's, organic products, sportswear. If you're into organic stuff, get that. And if there is any proceeds from this ever, they'll go to a different cause. Right now we're helping earthquake survivors in southern Turkey and northern Syria. So all of the proceeds go over to that. And then also, if you're on the live stream, let's see if we can get there again. Here, is this where we are? Yeah. If you're on the live stream, you can actually click right here where there's a little picture of a dollar bill or whatever, and it says show your support with a super chat gift there, and that proceeds also goes to help earthquake survivors. Stu is from Tauranga, New Zealand, and Mike is coming in from north of Atlanta, Ray from Glendale, Arizona. All right, so we've got about 7 minutes on this. Let's bring up the mids a little more. It's about the best we're going to do. Let's do our observation of NGC 3877, and we're going to say that it's near Chi Ursae Majoris, and it's a star in Ursa Major. So that must be this, and it must not be a double. So in Stellarium, that must be one of these. So this must be Chi Ursae Majoris. It's a cool looking edge-on galaxy. Reminds me of, I don't know, we have a galaxy we've looked at before. I can't remember the number on it. Remember they called it the Silver Needle? That's kind of what it reminds me of because we're looking at it so edge-on. Now we're starting to see some of these star-forming regions out there in the arms. The material that's being slung out. Pretty amazing, huh? Okay, so we're going to go to our next target. And for the next target, why don't we go to NGC 3941. NGC 3941. NGC 3941. And look at those pinpoints. Aren't those nice? Thank you, developers of Nina. What is the name of the guy who wrote that focusing algorithm in Nina? Joko something or other. Joko something. Thank you to him. We'll give a shout out, because look at these pinpoints here. It's amazing how finely tuned that autofocus is. What happens there, as you see that little squiggle, that's the mount adjusting so that it can be precisely dead on. And you can see we could put, well, you can't do it now while it's, finished resting from the plate solve. But in a moment, we'll put the crosshairs on, and you'll be able to see that. Of course, this is now waiting for the first image to come in. Frank, good to have you here, brother. Hey, I like your logo. Stellar Matters. Nice. Frank, good to have you aboard. So you can put this these crosshairs on as soon as that weight gets out of the way. Okay, there you go. And you see how closely the plate solving gets the object to the middle. We're going to drop these mids. We're going to reset our display histogram, and then reset our live stacking histogram. Reset the color. Bring the mids down to the beginning. Bring the darks over. We're using a brand new set of dark frames tonight, and when I say bring the darks over, I'm really talking about bringing the blacks over. You know, when you bring these blacks over, it's as if you're establishing a new threshold for what you're going to call black. In other words, this Louisville light pollution is so bad, you know, that's basically right. Let me see if I can make it look like Louisville light pollution. If I can simulate it. Well, oh, over here is where I need to be, sorry. Yeah, that's what it actually looked like tonight. With a 95% moon and the Louisville light pollution, the whole sky is really illuminated. So what we basically do is we say ignore all of that background illumination and define this as the new black. And with that as a new black, then we're able to see a little bit more in contrast this NGC 3941. Plate solver that we're using is ASTAP, I think. Let's check that to be sure. Plate solving, ASTAP, yes, A-S-T-A-P, ASTAP. Okay, so again, we're going to bring this up, and we're zoomed in to about 100%. Frank, have you been doing any streams, or are you just mostly doing observing with your, you have like, oh, I forget what it's called. Why do I always forget this? It's an 8-inch, isn't it? An 8-inch next star, what do you call that? Where you convert your scope into the equivalent of a RASA. You put the camera out there in front. 3941 is NGC 3941 is a barred lenticular galaxy. I tried to do research once on what does lenticular mean, and basically what I understood it to say is that it looks spiral-ish, but we can't see the arms. 8-inch SCT, 8-inch Schmidt Cassegrain Hyperstar is the name of that. It kind of converts it into a RASA, so you kind of get the best of both worlds. You can switch back to the SCT configuration for the long focal length, and then when you convert it to Hyperstar, it's actually, if I remember right, something like f4, a focal ratio of f4, so it's still really good focal ratio. Particular galaxy located in Ursa Major, around 40 million light years from Earth and 40,000 light years across, according to Stu. Stu, you're like a walking astro encyclopedia. This is a very small object in its arc minutes. It's just 3 arc minutes long and 2.5 arc minutes wide. It kind of looks like a little eyeball there, doesn't it? Doesn't it look like a little eyeball peering at us? If you get the new black level 2 black, it starts stealing photons away, so to speak, from the glow of the object. So you kind of walk this tightrope, don't you, between How bright can you make the object? Now I'm holding the shift key down when I fine tune it, because when you hold the shift key down, it moves these live stacking digital controls on a more like a more finely tuned gradation of adjustment. Okay, so let's see what Omira says about this real quick. 3877, right here it is. Oh, we already read this, didn't we? No? We're not at 3877 anymore, are we? We're at 3941. I need to change my little title down here, 3941. Okay, 3941. Can I just turn the page and find this easily? No. Gonna have to go to the, oh, here it is, yep. It's a relatively small but bright barred spiral, less than 4 degrees northeast of 61 Ursae Majoris. Has a high surface brightness, making a good target for small telescope users. A good target to see the brightness anyway. Very condensed, 2 arc-minute wide circular glow. Relatively bright and quite easy to see, 72 times the galaxy's very intense and round mass with a star-like nucleus. Larger scopes will show an outer envelope oriented north-northeast to south-southwest. Barred spiral, and of course, Stu calls it lenticular. Stu says a lenticular galaxy contains a large-scale disk but does not have any large-scale spiral arms. Yeah, pretty much exactly what we were saying there. Thanks, Stu, for reinforcing that. Okay, here we are at 200 times the optical zoom, and now we're into some digital zoom, but notice not enough to make it pixelate. Right there is where it starts pixelating. So we can get into 200% without pixelation. It's a good thing to remember. Seven minutes, it's about all we're going to get, but it is indeed like an eyeball. If we were to nickname this, let's nickname it the peering eye, something like that, galaxy. Okay, did we finish our observation? Looked like a peering eye. Can see a vague bar. Well, that's good. Stu, you have very good eyes. You're like William Herschel. You and William. Let's go to 3813. 3813. And we're not getting much out of stellarium in these. Once again, it's just the galaxy symbol. Nothing at all about the, no kind of picture. In fact, it's kind of hard to even make it cue up the object in stellarium. (3813). If you guys have tuned in before in other nights, you might remember that typically we have a camera trained on the telescope. For some reason it wouldn't come out tonight. We have another camera typically trained on the sky, 150 degrees wide view, and that camera wouldn't come up tonight. So a little bit stubborn these astronomical cameras can be, huh? So what we'll have to do is we'll have to come during the daytime and sort that out. 3813 is a very small and very dim galaxy, about 2.5 degrees north of 5th magnitude 61 Ursae Majoris. Small telescope users will need to star hop very carefully to its position and use moderate magnification to see it. Any light pollution will obliterate it, which is what we have here in Louisville. A lot of light pollution. Bortle 6 skies. At 23 degrees, it's extremely faint. You have to know exactly where to look to see it with vertivision. I suggest that once you get star B center in your scope, try switching to moderate magnification. It's visible as a roughly 2 arc-minute wide ellipse with a slight central brightening. Larger telescopes show the galaxy's halo to be more extended east to west, trapped in a triangle of 3 roughly 14th magnitude stars. That's the pupil of the eye. Yeah, good call, Stu. Okay, so the display histogram, the stacking histogram, the color balancing, the black level, and the zoom. Boy, that's a tiny object, isn't it? Wow. Super tiny. This is just 2 arc minutes long and 1 arc minute wide. A counter-rotating extended gas disk, which was possibly formed by a galaxy merger. How about that? That's fascinating. So this is a mixed up double whirligig. Has a counter-rotating extended gas disk, which was possibly formed by a galaxy merger, according to Stu. Ray says, challenging night. Is that for you out there, Ray, or you mean because of all these small objects? I would say quite a few of these Herschel 400 objects are small. I'm thinking about whether there'll be good weather for the Messier Marathon, just seeing how many of the Messier Marathon objects we can capture, but of course it would have to be good weather, wouldn't it? And it'll be so unique going back to full-size objects, you know, larger objects, won't it? Compared to all these 2 arc-second wide targets that we're finding in the Herschel list. That marathon would come up in March around the 18th, 19th. So, for instance, if Saturday night were available, we could do it then. Could probably do it Friday night, the 17th. I go to work Monday morning, so I bet we won't do that. But then again, I play soccer on Saturday and Sunday mornings. Go to church now on Sunday night, so play soccer on Saturday and Sunday mornings, and it starts at 8 or 9, so I'm usually getting up early anyways, but an all-night thing does not sound good. But we could try this on the 17th, couldn't we? Let's monitor the weather. That's a week from Friday. In other words, 2 weeks from tonight or 2 weeks from last night. And let's try a Messier Marathon. Let's see what the weather looks like for those. And if we can, we'll try to broadcast that entire Messier Marathon, and we'll just try to zip from one object to the next, 4 or 5 minutes on each object. Oh yeah, it was a challenging night for the stream and then also for those 2 cameras. Fortunately, it's not like in the main imaging train, but just means we don't get to see the telescope slewing around and kind of observe it inside the observatory, and we don't get to see the sky separately from this main imaging camera. So yeah, you're right, Ray, it's challenging. Frank says March 25th is the alternate. So yeah, I'm in Pittsburgh that night, so I'll be out of luck that night. I've got to do it either the 17th or the 18th. So anyway, we'll see how it works for those 2 nights. Going to zoom into about 200%. Boy, this is very fuzzy, isn't it? Wow, so faint. Looks like maybe some glow out here, huh? That's 5 minutes of integration. This is NGC 3813. Let's go over here to NGC 3813. Wow, that's beautiful. This was done with the Sloan Digital Sky Survey. Not sure how long they imaged this, but you can see the nice detail of those blue star forming regions. Look how these 4 stars frame it nicely. Little yellow core there in the middle. So here are the 4 stars framing it nicely. And look, here's that glow up at the top that we're seeing. Kind of makes a round glow around it, doesn't it? So that's the beginning of that glow we're starting to see here. It's almost like a little woolly worm, a little orangish, brownish woolly worm, huh? Flatwater 5, good to have you here. Stu says, better have the slew cam sorted out by then, if we can do that messy marathon, that's right. Well, I think this is going to be it. That's about 6 minutes and a half there, so we'll save that exactly as seen. And we could see the 4 framing stars, but couldn't make out much in terms of star forming regions. Flatwater 5, good to have you back. You're always so kind. All right, so let's go to next target, and let's run the, refresh things. I don't see any other objects in Ursa Major. I think we finished out Ursa Major for the night. So let's go to Ursa Minor. No, I'm sorry, this is L Minor. Is that, I forget, is that Leo? No. What's L Minor? Leo Minor? Surely not. Anyway, let's slew to NGC 3414. NGC 3414. NGC 3414. It's a galaxy in whatever L Minor is. I always miss this one. Is it Leo Minor? Let's go over to Stellarium and get that sorted out. Show chart. Yeah, Leo Minor. Well, I'm glad we didn't miss it this time, but still, you would think, because I remember we've tried to sort that out before. 3414. We'll go over here to Omira's book on the Herschel 400, and 3414 is on 115, so still in the sort of same section of the sky. 3414 is a very small and very faint lenticular galaxy near 44 Leonis Minoris. Small telescope users will need to know exactly where to look to see it with averted vision, think stellar-like. It's a very faint pip of fuzzy light that requires averted vision to see. If you go to substitute power, the galaxy is a concentrated spot of light with a tiny stellar nucleus. It's 2 arc minutes wide. So our first exposure coming up here. If you came in late, I did shoot new darks tonight and new flats. And darks and flats are kind of, you know, oftentimes a person with EAA wouldn't even fool with darks and flats because EAA is such a, you know, just a observational based hobby. The skill of electronically assisted astronomy is so observationally based that a lot of people would perhaps relegate taking dark frames and flat frames as a kind of astrophotography, you know, exercise. But in a way, I don't think that's the case. Let's see. I'm going to just see if I can mail a copy of the pictures I took tonight while I was taking the dark frames and flat frames. I'm going to mail those to the laptop that I'm on. These are the darks. And then this is where I was taking pictures of the lights, or flats, rather. Flats. Darks and flats, as you guys know if you're into astronomy already, there are two different kinds of calibration frames. And what these calibration frames do is they allow you to make up for some deficiencies that you might have in your imaging train related to maybe the inherent weaknesses. Let's see, save as picture, and we'll call this darks 2023-0304. And then this next one we'll call flats. So this is flats 2023-0304. And then I'll just look these up real quick. Pictures and the one we call darks and the other we called flats. So I just took these, this one I wish I could rotate it, but using it, maybe view, rotate view to the right. There we go. Okay, so the darks, let me come back to the screen now. This is the picture of us making the dark frames. So we've got a little shelf out there. We put our laptop on the shelf, and our wiring is set up so it requires almost no change. We've got a little flat screen out there on the wall of the observatory. We leave the lens cap on the scope, and we use SharpCap's little routine to collect darks, and it takes care of everything for you. It basically does 25 quick darks. It just doesn't take very much at all. You use your same temperature you're going to use. I go to -8 with the cooler built into this 2600MC Pro. You use the same temperature, use the same exposure, like length of exposure, 20 seconds. Use the same gain, again 100 gain. And then for the flats, we use a little light what would this be called? Frank, you were the one who put me onto this. What would you call this? Like a light projecting screen? And I just arranged the RASA so it's looking straight up and then set that panel. I guess it would be a light panel. And it's a very consistent light panel. And you just set that on top of the scope. You got to get one that's large enough for your aperture. And again, you go now to the routine and sharp cap that's made for flats, and it captures them for you again. And I was able to use the same length of exposure and same gain. It put my histogram way over to the right, but sharp cap said it's acceptable. So then when you're done, you just put that stuff away and come back in, and here we are. So now let's get to our image. This is 3414, and we're going to err a little bit on the left side. And boy, let's zoom in. Look how tiny this guy is. So that's at 200, and look, it's just a little wisp. Was it Omir that said it's like a wisp? 3814, right? No, 3414. 3414, it looks stellar-like, he said. It's just a concentrated spot of light with a tiny stellar nucleus. But look at the way we're starting to see, I think, some flat arms here. And we're looking at them edge on. So think Saturn. Imagine this as being Saturn. Boy, this looks like a little tiny galaxy here, doesn't it? And that looks like a very, 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 very faint galaxy there. Ray says those flats and darks do help with the image. I'm seeing this little flat spot here across that star-like nucleus. Let's bring this histogram over to try to reduce the sky glow. So you can see with me, that's 7 minutes right there. I think we would get more of this Saturn effect, the rings here. Flats don't need to be same length of exposure, temperature gain. Well, that's what I thought, but my flats weren't very good last time, Ray, so I decided I would try to keep them the same this time if Sharp Cap said it was acceptable, and it was, because my flats were just ugly last time, and this time, for some reason, they're better. So, I don't know. Next time I might mix it up and, like you say, not keep it the same. Okay, 8 minutes. We're going to go ahead and call it on this, but are you seeing the beginning of that edge? You have to look very closely to see the beginning of that little edge there. 3414. Is just two arc minutes wide, tiny. Looked like a little Saturn with edge on ring views at each side. I have done that before too, Ray. Shot at 35%. I've done the very same thing. Like I said, I was just trying to, as they say in Spanish, para sacar las dudas. I was just trying to take away all doubts because my flats were so ugly last time. They had this gradation in them and I can't even describe. It looked like sleet running down the side of a window sometimes, and I didn't like it. So I decided I'd try it this way, and sure enough, they do look better tonight. So something made them look better. I don't know what it was. Let's go to 3486 now. (3486). Well, that might have been that little galaxy I was telling you about, perhaps, right beside us. I don't know. maybe not. Anyway, it looks like we're at 3486. 3486 settled. 3486 also in Leo minor. NGC 3486. 3486 is a fairly bright spiral about 1 3/4 degrees northeast of 3414. It's obviously even at low power and a small telescope under dark sky. It's visible as an obvious 4 arc-minute by 2 arc-minute wide glow with a central brightening. At 72 power, the slightly oblong disk appears delicately mottled. 4 arc-minutes wide. So what we wait on in SharpCap is we wait on our little sequence to settle. And as soon as it does, for some reason, we have to stretch the display histogram again. Now, I want to tell you, I have a display histogram stretch built into the sequence. But for some reason, it never quite takes effect well enough. So we always have to do an auto stretch again. So here we are at 200 on this very small object. Again, this is 3486, and Omira said it was just 4 arc-minutes by 2 arc-minutes. But right away, are you seeing something that looks like it's being thrown out here? So I think this is a little bit nicer spiral, top on maybe. So face on, you might call it. At just 80 seconds, we're already seeing what looks like some kind of either a bar or a ring thrown out from that bright core. And see how this inner ring structure is forming up, even in the little confetti of the grain. I'm going to hold the shift key down and just go to the right ever so slightly to reduce that grain of the night sky. And we're already at 200%. I think any closer and we'll start to pixelate. Let's bring our mids up a little bit. Not much though. And look at that outer material start to form here. Is face on, so there's much more to see in those rings. The bright core, and I'll put in parentheses, relatively bright. Andy, good to have you aboard. Is star-like. But we could see material flailing out in all directions. Andy, remind us where you observe, where's your home? Where are you located tonight? You know what I think we'll do is go look at this in some kind of a Hubble astrophotography view just to get an image of what that material looks like that is flinging out there. This is 3486. NGC 3486. Sure enough. Oh, wow. Yeah, so what we're seeing is this material here. That showed up pretty quickly, didn't it? And then we're seeing a little bit here, and then a little bit all around, really, to be honest. We're not seeing very much of this star forming, these blue sections, are we? But that's just dazzling, this Hubble view, whatever that is. Let's see if we can see who did this. Yeah, that is the Hubble. It's a mosaic. The Hubble had to piece this together with different shots. Look, here's one shot, and there's another shot. The Hubble had such a narrow field of view, it couldn't even get this entire galaxy in one field. And then compare what we're seeing. We need a Hubble. Guys, can we, is it Leo Major? It says Leo Minor on our list. Oh, I see. You're right. It's Leo Minor. Thanks. Little typo there. Thanks, dude. Andy's in Clarksville, Arkansas. That sounds like you might have a darker sky, Andy. Clarksville, perhaps, I hope, gives you a darker sky than what we have here in the outskirts of Louisville. Boy, I tell you what, this little galaxy would be outstanding if we could just hang on it for a while. But it feels like that we ought to stick with our 7-minute. The Hubble view was amazing. Keep in mind, we're sure that Hubble stared at it for a long time. Who knows how long? Picture this telescope up there in orbit just staring at this thing, just continuing to stare. Moon is up high, sky is clear. Nice, Andy. Yeah, we've got a 95% moon here in Louisville tonight. That's part of what we're battling. But again, with EAA, you kind of forget that it's there, actually. All right, that's 6 minutes. Yeah, look at this material out here now. In all directions. Well, that's actually rather nice to pull it over here on the left side, isn't it? And then bring those mids up. You can see a lot more of the structure, but unfortunately we see a lot more of the confetti in the sky, don't we? The grain of the sky itself. Okay, there's 6 minutes and 40 seconds. So that took care of NGC 3486. Also in Leo Minor is 3504. 3504. As a part of our sequence, when we're in between objects, maybe you're noticing that you can see the star movement through the telescope that's attached to the RASA, this main imaging train camera. You can see that movement because in between objects we reduce the time exposure to 3 seconds. And we increase the gain to 400. So what that does, at least it lets you see a little bit of the telescope movement from the camera that's attached to the front of the RASA. Again, that looks like this. That camera that's attached to the front of the RASA looks like this. So when the RASA is turning, you're kind of seeing the night sky through that main imaging train camera here on the front. And that's what you're seeing. Like right now, the little bit of skating of those stars, it's just due to the movement of the plate solving that we have built into the sequencing. And it at least lets you get a sense of the telescope's movement rather than keeping it at the 20-second time exposure. Flatwater 5 says, Arkansas is amazing. He took the last train to Clarksville once. Take the last train to Clarksville, and I'll meet you at the station. Do 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 do. Oh no no no. Oh no no no. Do 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 do. Well, if I sing any more of that, I'm sure I'd have to pay some kind of copyright fee, so we're not going to do that anymore. No, I'm just kidding. It's not recognizable enough when I sing it, so let's see, we're going to auto stretch the display histogram and back off these mids quite a bit. Wow, I'm not seeing this object at all yet. Oh, right there, I think it might be in the middle. So we're going to zoom in and get all of our digital zooming to about 200%. And there's the object. It's kind of like being on a treasure hunt, isn't it? It's another spiral, isn't it? 3504. Could you explain what you meant about temperature settings? No passenger trains here anymore, only freight. That's a shame. The monkeys would be out of business. Temperature settings. Maybe Flatwater 5, what you might be talking about is when I was talking about the cooler that's built into the camera, perhaps, maybe. Is that what you were referring to? We do have, in this camera, it has its own cooler built in. It's a tech cooler, so it's actually like having a little bit of a refrigerator attached to your camera. And we can usually get 40 differential degrees, maybe 30 differential degrees from what the outside temperature is. So right now, the outside temperature is 40 degrees, 0.5. And at the sensor of the camera, it's running at -8. So that's a 48 degree differential, isn't it? No, more. 40 degrees Fahrenheit would be 40, oh no, this is -8 centigrade in sharp cap. So that's 16 below 32. So it'd be at 16 degrees Fahrenheit. So we're cooling this camera from 40 down to 16 Fahrenheit, I believe, if my math worked. From 40 down to 16. We just keep it at -8 all the time, just year round. Because that's it never gets colder than that. And it seems plenty cool for this camera to never see any of those hot pixels if we're using darks. So -8 is the coolant temperature that we use, and that keeps the sensor cool, because if you let the sensor get too hot, like 60 or 70 degrees, I assume, then there would be more of those hot pixels showing up that are kind of like misfiring, and they misfire in all kinds of ugly colors like greens, and they'll be right out here with your stars. And since hot pixels don't move with the nighttime sky, but we're moving with the nighttime sky, hot pixels drag, like skate across. They make little trails, and they're ugly. So dark frames, dark frames help your camera plan for those bad pixels. The camera can say, oh my goodness, even if I have a lens cap on and I take a picture, that pixel is still firing. Well, it's firing because it's broken. So what the camera does is it automatically turns that pixel off as far as gathering the image. And it doesn't even use it anymore for the life of the camera. Of course, the camera has like 6 million by 6 million resolution, so losing a pixel doesn't matter to the image, but boy, if that pixel is lit up, it just glares at you. So ugly. So it's a way of helping your camera compensate for a broken pixel. That's what the dark frame does. I hope that helps some, Flatwater 5. It's not nitrogen, I don't think. I think it's an electric cooler. I don't know which gas. And Ray is right. Flats, for their part, they don't care about temperature settings. You just take them anytime as long as the camera or any part of the imaging train hasn't been moved. And that's one of the reasons why we love an observatory, because we don't have to move this stuff. Okay, so again, we're looking at 3504, a galaxy in Leo Minor. This is actually a pretty cool little galaxy. Look at that. I don't know what to do with this. Let's make that a little bit brighter by moving these mids up. 3504. Is that right? 3504, yes. Should be in the same general vicinity here, but I don't see it, so I'm going to go back to the index real quick. NGC 3504 is on 116. I went the wrong way. I should have turned back to the left. O'Meara says it's a very small but reasonably bright spiral galaxy, very dim under low power, brightens up significantly with magnification. It's 1 arc minute wide, 2 arc minute long. Its core is quite bright, with a nucleus that's stellar-like, yep, and the surrounding halo is dim and ill-defined. We're getting a really cool surrounding halo, though. Look, you can see its edge on, or maybe a little bit cantilevered, 20 degrees maybe, cocked, but it's a beautiful little spiral for no more time than we've been on it, 6 minutes and 40 seconds. Flatwater says, thanks to Ray. We're going to save a copy of this. And see, it's 9:45. I bet we've been going for almost 2 hours. Let me go look for a second at our stream and see if it tells. Does it tell how long we've been going anywhere? It doesn't. Nowhere on here. It looks like maybe it was. Let's see, that's 10 minutes, so around 8 o'clock. So let's go 13 more minutes. Wow, 208 different people have logged on at one time or another. That's kind of fun. This next object let's go to is also, it's in Leo. And let's see, did we finish the 3504 observation? No, we didn't. Let's say we could see a great little edge-on halo. Again, Saturn-like, but puffy. Bright core. 102 minutes ago. Thank you, Andy. Let's see. So we're going to run this and go to now Leo 3412. 3412. 3412. So they don't say Leo Major, huh? They just say Leo. And then for Leo Minor, they say Leo Minor. just when I was getting used to things like Canis Major, Canis Minor, they don't do that with Leo. Wonder why that is. 3412. Okay, we've settled. 3412. Well, we're going to have to go back to the index again. 3412. I like the fact that we upgraded 3412. See page 111. I like the fact that we upgraded our internet speed here. We're at gigabyte internet now the whole way. So I like that. But it did seem to throw us for a looper if that's indeed what caused us to have a tough time with the stream 3412. With the stream, what would that be called? The stream key or whatever. 3412 is a small and somewhat dim barred spiral galaxy about 1 degree southeast of NGC 3377. So let's do that one next. 3377, if we can find it, if we haven't already done it. It says, while it is easy to see in large telescopes, the galaxy could be a challenge for small telescope users from suburban locations. It's a small 2 arc-minute wide ghostly glow that looks irregularly round with averted vision. At higher magnifications, the core intensifies, and its form can be seen drawn out from northwest to southeast. In larger telescopes, the galaxy appears more condensed and intense, so it's easier to catch. 3412. Again, we're going to... Bring down these mids. There it is. Right in the middle. $200. It does look blob-like, doesn't it? Blob-like glow. We're going to just show chart here. And here's where we are in stellarium. This is east and that's southeast. So it's east, southeast. By the way, this building is the building I'm in. And that window, barely visible over there, that window is where I'm sitting. I mean, not on the window. Inside the office where that window is located is where I'm sitting. About 200 feet away from the observatory. So you see we're looking over the top of the observatory here. And we're up about 44 degrees on this object. There's the moon. Look how close we are to the moon. Rats, I do that sometimes. I forget and use the... So here's Leo. Look at that backwards question mark that looks like the lion's head and mane, and then the lion's front feet. And look at the body of the lion, and this is the tail. Don't you think Leo is one of the few constellations that actually looks like it is? It looks like a lion, doesn't it? Anyway, right here is the object we're looking at, and see once again, stellarium offers nothing. So these objects are so small that they don't really pick up any detail at all. Over here is the Leo triplet, whatever you want to call that. The Leo trio. So we're at 3412 right here. It does have a little bit of fluff out now, doesn't it? We'll make the sky slightly darker. Hopefully that'll create a little more contrast. And we'll bring up the mids here. But at 3 minutes, that's the best we can do. 3412. Looks like a little bit of bow tie there, doesn't it? Ursa Major should just be Ursa. That's right, Mike. We should put in a suggestion to the International Astronomical Union, if that's what it's called, IAU or whatever. We should put in a suggestion that they should call Ursa Major Ursa. If they're going to call Leo Major Leo, we should call Ursa Major Ursa. Flower 5, that's nice of you to thank me for the talk about temperature as well. So I really like these new flats and darks tonight. I was getting a lot of ugly vignetting with the flats that I was using. I don't know why, but they were just skewed for some reason. Flats, see, we talked about darks. Let's talk about flats. Flats take a look at any of the problems that your imaging train produces at light. So for instance, if you have a dust glob on your, like in our case, we have the corrector plate up front. If you have whatever, dust or fingerprints on the camera, then what those look like in the image is irregular blobs, and they're ugly too. So with calibration frames called flats, the camera looks for those adjustments. Like for instance, I'm going to back off here to 100% and see if we can see any. We're not seeing much at all now. See how this entire frame looks equal in darkness. Let me see if I can introduce some noise to it and just overrun the flats. Okay, right there. See how right there, we're just barely starting to see a little vignetting out here? Now that would be much worse without good flats. And I like these flats a lot more now. My RASA has a little bit of vignetting there because the APS-C camera is a pretty wide frame for it, pretty wide sensor frame for it. And those flats that we shot tonight are doing their job to help us make that fairly flat tonal spread of your image. I wonder what this looks like to a Hubble. That's 6 minutes. See that outward blob? Let's look at it real quick. This is 3412. NGC 3412, and then I put the word wiki. Yeah, it's pretty much the same thing we're seeing, just that outer blob and then an inner star-like core. See this outer blob and then an inner star-like core, pretty much the same thing. We're only at 7 minutes. If we could go for, 6 hours, which this image is probably a 6-hour image. If we could go 6 hours, then we would see that as well. That was done at the Sloan Digital Sky Survey. They don't ever tell you how long they ran, but I bet that was a 6-hour photo or so. I don't know. Who knows? Okay. Last image. Did we do an observation? This we didn't, did we? We usually do, for the last image, we do something special. This was blob-like, but yet we could still make out some bow tie pattern in the blob. Hubble or Sloan Digital Sky Survey confirmed. For the last image, we sometimes go to something that's a little more, a little more fun. Do you guys have something in mind that you'd like to suggest? The moon is up there, don't forget. For instance, Andromeda is a little too low. What would you guys propose? Heart Nebula, maybe? What are you thinking? The moon would just be really bright. Seagull's wings. What are you feeling, guys? Rosette Nebula? The lost jewel of Orion. What is that? Oh, that would be pretty. The M45, you know. Pleiades, Black Eye Galaxy. Black Eye Galaxy. Yeah, that should do. Black Eye Galaxy. So current object, SLU. Do you want to go to the moon, Alice? Do you want to go to the moon? Have you seen the new JWST image of Pandora cluster? I have not, Stu. We'll have to check that out in a minute while this is gathering light. Black Eye Galaxy. Right there it is. We don't need to plate solve. So let's whoops. Let's go at 20 seconds again and 100 gain. And clear the live stack. Okay, Black Eye Galaxy is NGC 4826. Wonder if I can go, let's see, save this. I doubt if the Black Eye Galaxy is in the, let's ignore and put it in order. I have these set now so I can put them in order. The 4826, is that in the Herschel 400? No. So we're going to have to change files to something like observe next and add it's a little bit of trouble here. NGC 4826. And then you can observe it. Observation, add observation. Wow, it's looking good tonight, isn't it? The black-eyed galaxy was looking good tonight, in spite of a 95% moon and Bortle 6 skies. Is it M64? Black Eye Galaxy. Yeah, M64, way to go. M64. It always looks sleepy to me. Instead of a black eye, it looks like a sleepy whale. Sleepy, you know, like look how the reds don't want to auto balance. That must be a moon thing. I'm going to bring the reds down a little. Get them to balance with the rest of everything else. There we go. Now, let's bring the mids up. Boy, that's just a beautiful galaxy, isn't it? Good pick, Ray. UGC 4459 also, is it? Yeah, UGC 8062, I think. Also called Sleeping Beauty Galaxy. Also called Sleeping Beauty Galaxy. Or Evil Eye Galaxy. Boy, it's amazing, isn't it? Wonder how far that is. You think Stellarium tells us? $24 million light years, I think. 24 million light years. It's about 10 arc minutes. That's what I say. These are so much bigger. So that's like 5 to 10 times what we've been looking at in the Messier list compared to the Herschel 400. 24 million light years away. Discovered by Edward Peugeot in March 1779. Then independently by Johann Elert Bode, however you pronounce that, in April same year, as well as Messier the next year. How about that? The Droopy Eye, that's the name, Droopy Eye Galaxy, according to Ray. Well, we'll end here on the Droopy Eye Galaxy. Hey, I'm really grateful to you guys for sticking around in the beginning of the session when we couldn't quite get the stream key worked out. We'd upgraded internet here. Maybe that was why. There might have been a problem with the firewall. So we ended up creating a new stream key. And then we had to find the place to put that in the broadcasting software we use, which is OBS. And only when we got the stream key created correctly in OBS did it finally lock, and we were able to start about 20 minutes late. So you guys were really patient as we were getting going there. Another thing I thank you for tonight is putting up with the fact that we don't have the scope view. We'll try to get that working. That camera just failed to start tonight. And we also don't have the sky view camera working for some reason. We'll try to figure that out. We'll get all those worked out for the next stream when we welcome you back. We'll look for any clear night. We try to do one clear night per week minimum. And we'll look for the next clear night and try to be back. If we're out of town for a week, that sometimes throws us off, and we sometimes go 2 weeks because, for instance, I was out of town last week for a week in California, and so that sometimes throws us off. But for the most part, we try to do the best clear night per week that we can get on. You know, thanks so much to God for making all these cool objects. I mean, just look at this. The droopy-eyed bull, or the droopy-eyed whale, whatever you want to call this. It is beautiful, isn't it? This is M64 or NGC 4826. I'm going to change the name here, NGC 4826, and change it down here as well, NGC 4826 M64. So thanks to God for making all these great images for us to look at, like Easter eggs up there in the sky that we can discover. Thank you for the time you invest. If you don't mind subscribing, if you like content like this, if you think it's been worth it, I wish you'd do the thumbs up or the like. You know, if you click on that bell, then you'll be notified when we do content like this. We always try to create the live stream prompt a day before, like 24 hours in advance. And that way you'll be notified. If you check into YouTube, you'll be notified that we're coming. Thanks to all you guys that observed with us simultaneously. Andy, I like it, the whale eye. That's what we should have called it. Thank you, David, for being here. Stu, you're always good to log on from Tauranga, New Zealand. Flatwater 5, hit the thumbs up. Thank you, brother. God bless you guys. Have a good evening, and we'll see you next time from Emerald Hill Sky here on the edge of Louisville, Kentucky. God bless and have a great evening.